Once an item has been resolved, it can't be resolved again. This is because it can only take one particular form. And of course it must be resolved at some point. So on that table you'll see that items will tend to have a no, no, and then once yes occurs, they'll then be not applicable after that. So do study that table to see that format. We also use a universal language format for describing the interfaces. This is because the BI3 is an abstract specification and it doesn't dictate the language or environment that the system will be constructed in. So there's no point using C or Java to describe that when it's really could be machine code or could simply be a hardware implementation in, say, FPGA. It's field programmable gate arrays. So what we do is we use a universal language that can be mapped into the local implementation, but it's formal enough to describe the inputs and the outputs. And we've used one that you won't really program with, but it's simple enough to understand. It has multiple returns and multiple parameters and a basic class and object orientated format. So we'll just be using that in describing the inputs and outputs to the TACE alpha environment. If we look to the circuit layout, we can see that the alpha environment is a very basic von Neumann processor. It has a CPU and it has random access memory which is connected by a bus. It also has another microprocessor which loads the fixed program images into it. So this is similar to what a disk would do. The difference here is that it's very controlled and it can only load those particular images in so that these images will replay exactly the same time and exactly the same manner each time they're executed. Factory loading is an event that occurs on the first run of the emulator. The factory load executes in a privileged state so that it can access resources and compress and put these into a tamper-resistant form. The second time the system runs, this is entirely different and the system will operate normally. Booting occurs from the second run onwards, and booting follows a specific sequence that ensures that the TACE alpha environment stays consistent and produces the same result each time. In normal operation, the instructions can change the values of the registers on the CPU, or they can access data stored in the random access memory. They can also shut down the program. It's important that the TACE alpha environment emulator, the BI3 TAE, does not increase the speed of execution once some of these programs have been halted. Finally, we look at the interfaces, and there's two basic ones specified in the TACE emulator. The first is the BI3 TAE, and that is a class that describes the emulator itself, and it has privileged access and it can shut down or start up the system. The second interface is the process interface, and that's what the software running on the emulator is controlled by. Very simple machine. And that's the end of the second milestone. The third milestone follows shortly.